All right, last section in Chapter 7 is on percents and interest. Obviously some pretty big ideas with decimals. And we're going to start by talking about what these things mean. So percent is actually a word that comes from the Latin meaning per 100, as in our cent. When we talk about a cent, a penny, it actually is 1/100th of a dollar. And that means that when we write down in percent, it means that value per 100. That's what that's actually meaning. There's a couple of ways to turn numbers into percents, and these aren't like this isn't an exhaustive list. This is just a couple of options for doing this. One way is to write the number as a fraction with a denominator of 100. So the number itself, 7.9, can be written as 790 over 100. It's the same thing. This is sort of the equivalent to multiplying something by 100 to turn it into a percent, and that becomes 790%. Another way is to use a proportion, and you might feel kind of like this is awkward, but if you're dealing with something that's a fraction and you're turning it into a percent, it's kind of nice sometimes to not go through the decimal phase. And so you can do it directly using proportions, and of course from using proportions you know that you can cross multiply. And again, you end up taking the 7.9 times 100 in this case. Okay, so these are a couple ways to think about it. We're going to do one of each of them here. So on the first one, 42.6. If you're turning this into a percent, it means writing something over 100. Well, if it was already written over 1, and you're now going to write it over 100, it means you're multiplying by 100. So if you take 42.6 and you multiply by 100, what do you get? Four, 2, 6, 0. You guys don't want to talk today? Okay. All right. So, and a lot of times too, when you think about multiplying by 100, you think about moving a decimal place two values. So that's an equivalent description. And then since it's expressed as a number over 100, this means that this is 4,260%. Okay. Now, it feels awkward to write that big of a percentage, but it's a legitimate value. We don't see the values used quite like that so often, but it is legitimate value. The second one, I purposely gave you something in fractional form because I wanted to show you how the proportion is nicely used. So we're going to set this up as a proportion. This would be n over 100. And then we can cross multiply. So I have 3n equals 800. And then what would I do? Right, divide by 3. And then if we take 800 and we divide by 3, what do you get? You get a 2 here, right? Then what? 6 repeating, yeah. So when you do this, what ends up happening is you get a 20, and then the 20 goes in 6 times. And this is the one where you get the repeating part, because 6 times 3 is 18, and you get another remainder of 2. So the 6 keeps repeating. But it actually doesn't repeat, like I don't want to write 2 and then a decimal point and 6 repeating. It's 6, 6, and then the 6 repeats, right? Because the repeating part has to be after a decimal point. So this actually ends up being, you can write it one of two ways, 66.6 repeating percent, or you could write this as 266 2/3%. Both of those would be perfectly reasonable descriptions of this. I'm going to guess you guys are going to probably go with the first one of them, but the second one you might see written sometimes. You should know what that means. All right, we also want to go back the other direction. That is, we want to take a percent and turn it back into a decimal or a fractional value, depending on what we're working with. So on this one, at first it's a little bit awkward to have it written as a fraction, so I'm going to write it as 4.5 because I can. I mean, it's the same expression. So what we're wanting to do on this one is we're wanting to take the value and we're wanting to place the value over 100. Well, dividing by 100 is the same as doing what? Yeah, moving the decimal 2 to the left. So if I move this decimal 2 to the left, what do I get? 0.045. And it's not a percent anymore, right? It started out as a percent, now it's in a decimal form. And we can do the same thing on the bottom one. We can take 125 write it over 100 and recognize that this is equivalent to saying moving the decimal 2 to the left, which gives me what number? 1.25, right? So typically converting between decimals and percents is not a difficult topic for you guys, I'm sure, and probably not for most of your students because you are just simply moving decimal places around. But it's important to realize why you're moving around. You're moving around because you're either multiplying or dividing by the number 100, okay? All right, what we're going to do next is we're going to actually talk about applications of percentages, okay? And do you remember back in section 6.4, the last section in our last chapter, it was all about proportions. And in fact, some of you, I know you felt like this, like I can do these problems in a different way. Why the issue about proportions? I mean, what's the deal here about using proportions? Well, we're going to do it again here, and the reason we are is, well, the reason we did section 6.4 in that form is because section 7.4 in this form works so well. Okay, so now you're going to see the fruit of your labor from 6.4 and how nicely it fits in with 7.4. So there are three different applications that, or three different forms that a percent application can take. One is finding the percent of a number, and so I'm just going to give you an abbreviated example of the language that it looks like when you do this form. So this sounds something like this. What is 15% of 32? Okay, so maybe you have a $32 bill and you want to tip the waiter 15%. What is 15% of 32? Okay, it's finding a percentage of a number. And not that 15% is special, but it's also the same kind of question when you say, what is 10% of 50? You know, like in terms of your tithe that you give to the church or something like that. So this is finding a percent of a number. The second one is finding what percent one number is of another one. So this one looks something like that. What percent is, of 47 is 12. Getting carried away with my percents there. What percent of 47 is 12? Okay, so you're given two numbers and you're actually looking for the percent in this one, right? And then the last one is finding a number when a percent of a number is known, which sounds awkward to even say, but let me write down what it looks like. So we would say something like this. 13 is 45% of what number? Now these last two are used a lot with sales, like this when I put an item is on sale. So if you talk about something being, 50% off, 30% off, 22% off, whatever the percent off is, you can actually either find the original price or find the sales price using these last two forms. You can also sometimes look at a price of a product and say, hey, look, it started out at, $4.22, and now I'm only going to pay $3.26. What kind of a sale? What kind of savings am I getting? Not just in numbers, but in a percent. What kind of a percentage off is this? And so that's the kind of thing you're seeing on the last one. All right, so what we're going to do is we're going to do some examples. And as we do the examples, we're going to identify which type of problem it is. Okay, is it the first type of problem, the second type, or the third type? All right, so the first question says, what is the sale price of a softball if the regular price is $6.80 and there is a 25% discount? Now here's the cool thing with these problems. These are problems that are going to be set up with proportions. So you already know that your basic form looks like this. One side of the equation is going to be about the percentages, and the other side is going to be about the sale or the price or the original size or whatever the context is in your problem. So for instance, on this one, there's a 25% discount. Now you have to be careful about what you're being asked for. The regular price is $6.80, and we want to know the sale price. So everybody gets tripped up in this, not everybody, but a lot of people get tripped up in the language here. If there's a discount of 25%, how much are you actually going to be paying? What percent of the product's price? 75%. Now, there's a couple of ways to do that. I'm going to deal with the 75% and go with it from there. And then I'll go back and I'll show you how to do it with the 25% and do it from that perspective too, okay? So I think that the easiest thing to do is to actually recognize what you're actually going to be paying. Because this question wants to know the sale price, not the savings. The savings would be the 25%, but the sale price is the 75%. So one side of my equation is 75 over 100. So this is my new price, and this is my original price. So where does the 680 go? On bottom, it is the original, you're right. So the 680 goes down here, and then what I don't know is the sale price, the new price, and that goes on top. So I can solve this in a proportion form because everything has its place. We can cross multiply. You get 100x equals, so what is 75 times 6.8 or 680? $6.80. Is it 510? Okay. 510, and then what? Divide by 100, you got it? And what do you have? $5.10. Okay? So this is way number one, if you will, of solving this problem. Let me show you an alternate way if you, maybe you didn't catch the 75% at first and you already started the problem, and so you already solved it once and you don't really want to start all over again just because you used 75 or 25% instead of 75%. I'm going to show you what you could do. You could set up the problem as x over the 680 and the 25 over the 100. So somebody tell me what is 25 times 680. I don't have this one written down. 25 times 6.80. 170. And if you divide by 100, you actually get $1.70. The point, not the point, the problem is that at the very end you have to ask yourself what you found. So what did you find when you found 170? Yeah, this was the amount off. So if you get to this point and you realize, oh, I found the amount off, you don't need to redo the problem. What could you do from this point? Yeah, you could subtract. You could just take the 680 minus the 170, and you'll still end up with 510. So the problem can be done either way. It's just that if you choose to do it the second way, you have this extra step at the end to remember, and you might forget. So, you know, that's kind of the drawback possibility. What type of problem is this? You've got the original price that you know the discount amount. What type of problem? 1, 2, or 3? Is it? Is this type number 1? Let's go back and look at them. Type number 1, oh wait, hang on. Yeah. Type number 1 is finding the percent of a value. We know we were finding what was 75% of the $6.80, right? How much of the savings it was. So this is a type number 1 problem. All right, let's do another one. Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. That's good, right? Yeah, good job, Mort. What is the approximate percent of increase in the value of his house? So, first of all, let's just answer the question at the bottom. Which type of problem is this? Which is it? Number 2. How do you know? Given 2 numbers, there's no percentage given, right? And in fact, it even tells me find the percent, right? Approximate percent. So we're going to be looking for a percentage in this problem. That also helps us in terms of setting the problem up. We don't know the percent, and we've got the 100 on bottom. The 100 is always going to be on bottom of one side, so you get that one for free. All right, now you have 2 ways to set this problem up. We'll set it up both ways. So somebody give me a suggestion of how you think you might set up the other side.
The 195,000 on top.
Okay. And then what?
The 159 on bottom.
Okay, yeah. So this is the new amount, if you will, compared to the original amount. This is one way to set it up. Okay, let's go through the problem as it's set up this way, and then we'll answer the question based on this problem's answer when we get done. So if I cross multiply, I have 159,000 x equals 1,950,000. And then I divide by 159,000. And your calculator is your best friend right now because you don't want to do that by hand. What do you get? Okay, let's stop there. That's fine. For the most of the time, we'll go with whole number percentages, but it's okay if we had a couple decimals as well. Now go back to the question that was asked. This is a percent, and we found a percent. But the question asked, what is the percent what? Of increase. Did we find the percent of increase? What do we actually find? The percent of the entire new house, the entire house now, right? What would the percent of increase be based on this answer? Do you know? Right. So the percent of increase, whoops, would be the 22.64% or 23%. It did say approximate, so 23% would certainly be a reasonable answer. So this is kind of like doing that last problem over here the second way. When we get to the end, we have to actually examine what in the world we actually found and how it answered the problem we were given. Yes, Adrian? Yep.
I forgot a zero.
Where?
So 195,000 times 100.
Oh, is it 19 million? I may have. I was moving through that awfully quickly. Does that look better? Okay, good. Thank you for catching that. Okay, so this is equivalent to us having done the problem the second way that we did on this example, where at the very end we had to make some sort of a decision about our answer and did it answer our question. There's another way we could do this problem in the way that we set it up that would mean that the answer is exactly what we find when we find x equals at the bottom. Do you have an idea, Bridget?
I was just wondering what happened to the one in the 122.64.
It's the original 100% of the price of the house. So the percent that it increased was 22%. It was originally worth 100%, now it's worth 123%. That's what happened to it, yeah. Hang on, I'm trying to give us a little bit more space to work. Let me not just move it all over. All right, let's try the problem one more way because we can do this directly and then not have to make those decisions at the end if we're a little more careful in our setup at the beginning. Now, we can still write the x over the 100, and the original denominator is still 159,000 because that's the original price of the house. What's different is what goes in the numerator.
Can we subtract them?
Yeah, we could. It actually asked us for the percent of the increase of the value, so we could actually just figure out, well, what is the increase in the value? I mean, how much did it increase in value? So we could actually, at the very beginning, go 195,000 minus 159,000, and what would we get? Right. So this 36,000 is actually the value of the increase. So instead, in this problem, this x is representing the increased value instead of representing the newer value of the house. And then when we solve this problem, here's that 159,000. And then I think this one actually does give me 3,600,000. Does that look right? Do I get all my decimals in the right place, or the zeros in the right place values? Oh, sorry, where's my x? Here, there it is. And then we divide by the 159,000. So if we do that, take your calculator, divide, what happens? Yeah, we just get that 2264 or 23%. For the most part, whole values for percentages are acceptable, perfectly fine. Any questions on that one? I want you to know you can do it either way. It just depends on how careful you are in the setup versus how careful you want to be in the setup versus how careful you want to be at the end. Somewhere along the way, you're going to have to pay attention to how you're thinking about the problem to know whether or not you got the right answer. So somewhere in there, you're going to have to do that. Another one, a ski area. Skiing's been on my mind a lot lately. We're headed skiing for spring break. I want to go. Ski area reports that 80% of its runs are open. If there are 60 runs open, how many runs are at the ski area? Which type of problem is this? It is the third one, yeah. It's the third one. It is, how did I write it? We're going to find a number. Our answer is going to be a number when the percentage of the number is known. So we know the percentage of the number. So in terms of our setup, it always starts out again looking like a proportion with a 100 on bottom. This is the guaranteed setup every single time, okay? Then you have to figure out where other things go. Well, the easiest thing next to figure out where it goes is the 80. Where does the 80 go? Yeah, above the 100 because it's a percentage, right? Now you have to be careful. Where does the 60 go? On top, across from the 80, like this, right? Because this is the amount that are open. On one side, it's the actual number, the left, and on the right-hand side, it's the percent. And this is the full number that exist, the full amount of slope or runs that exist. And we have to divide that by what we don't know. For now, it's x. So I have 80x then equals 6,000. And if we divide, what do we get? 75. So there are 75 runs. Okay, any questions on that one? Pretty okay? All right. We're going to do some mental math in this section as well. So thinking in terms of some mental math, I want us to go through and actually I'm just going to let you take a second and write them in before we do it as a class. Write in the fraction that corresponds to the percentage that's given. Okay, so now for the most part, I would say you probably like thinking about percentages better than fractions. They make a lot of sense to us. But there are some cases where the percent and working with the percent is actually more convoluted, a little bit more difficult to actually work with straight away than to work with fraction for the value. So it's helpful to know both so that whenever the situation does arise, you have an option. So what is the fraction for 25%? Right, 1/4. How about 50%? 1/2. 75%? 33 and 1/3%. 1/3. 66 and 2/3%? That is 2/3. How about 10%? 1/10. And 1%? 1/100. All right, so what we're going to be doing on the next slide is we're going to be actually thinking about some of these with the fraction form, some of them with the percent form, and some of them we have options of. But we're going to be using mental math. So I always think it's tricky to grade mental math because I can't see your brain. So you have to show me written down a little bit about what your brain's doing so I can see what's going on inside there, okay? So I'm going to kind of model that for you. So reference this when you're looking at your homework and thinking about what is she expecting to see so that you can kind of have a sense of that. 15% of $42, we're going to start right there. Now 15% is not convenient as a fraction or as a decimal. It's just not. But it can be broken apart into some very convenient things. Like what? Okay, so we can break 15% into, say, something like 0.1, which would be 10%, and 5%. So how do we get 42, how do we get the 10% of 42? Yeah, we move the decimal over, so what do we get? 4.2. And then what would we do to get 5% of 42? Half that, exactly. So, and I'll just write that and jot this in here. We're going to half of the 10%. So the values that we're actually working with the 4.2, that would end up giving me 2.1. And then what are we going to do with the 4.2 and the 2.1? We're going to add these together. And if I do that, what do I get? Yeah, 6.3. And this problem was given to us in terms of money, so we'll give the answer in terms of money. I should probably write 6.30 even. That would make more sense. Okay, does that make sense? How about the next one? What are you going to do to get 20%? Okay, so you would break it into like a 10 and a 10. So we could do that, and we could find the 10%. So let's start there. So what is 10% of 280? 28. Good. And then what are we going to do? You could just multiply by 2, or you could add it to itself, right? Either option. So this is doubling it. So 20% is double. That's what we did. So what is 28 times 2? 56. And again, it's dollars. Okay, C is a variation of A. It says 5%. So what do we do to get 5%, or at least one way to do it? Yeah, we find 10% and we divide it by 2, right? That's a convenient way to do that. So we're going to take 10% and divide by 2. So what is 10% of 28? 280, right? And then we're going to divide by 2. What's that going to give me? $1.40. Thank you. Somebody's going to say it out loud eventually. $1.40. You betcha. So $1.40. Last one, 25%. There's at least 2 ways to do the problem, and they're both perfectly fine. Somebody give me a thought when you saw 25%. What could you do? Yes, Amanda? That's the easiest way. Very good. This is a good example of where this chart over here becomes actually quite helpful. The easiest way, and it also works really nicely because 84 is evenly divisible by 4. So obviously that's sort of playing into why that's nice. So this corresponds to the fraction 1/4. So you can take 84 and divide by 4 to give you 21. If you didn't think of that, what did you think of? Because there's another option. Okay, so you could do half and half twice. That's true. You could do that. I didn't even think about that, but that would work too. What else could you do? You usually have students that want to do it like number 1, where they want to find 10% and double it, and 10% and half it, and then add those values together. Like break 25 down into 10 plus 10 plus 5. That's the hardest way to do it, honestly. It's not terribly hard, and I don't want to say that, but it's the longest processed way to do that. Either the other options that you guys mentioned, either dividing by 4 or dividing by 2 twice would be a quicker way to do it. So, all right, there's one more topic in this section, and I think we have one more example before we get there. So, let's do this. 2 more examples. I'm sorry, one more slide. All right, so example number 7 wants us to answer the question: does 0.4 equal 0.4%? Oh, I see lots of shaking heads. No, why not? Oh, that's a very good description. So 0.4, we could write it as 4 over 10. But this number would actually be, hang on. We want it to be written as something over 100. We'll do it this way, like you just said, which would mean it's the same thing as actually 40 over 100, right? Or 40%. This value right here, this is where I was headed otherwise, let me do that one too, is already a value of 100, right? That's what it means to be percent. So if you turned this, instead of turning the other one into a percent and comparing them, if you turned this one back into a decimal to compare them, this is actually what number? You know? Yeah, 0.004. So you can either compare them in percentage form or you compare them in fraction or decimal form, either way. You don't need to do both. So either of those options is a good way to compare them. So this you could say, for instance, at the end of this, you could say this does not equal 0.4%. So if you chose that way, if you chose the red way, you could say that this does not equal 0.04. Sorry, 0.4 that you started with over here. Okay. I'm not going to write the explanation down. I've said it out loud. You guys have said some of the things out loud too. Of course, we would want to write that down if we were working a problem on this for your homework. The idea being that, like, if you went with the black direction, the black way, that like Amanda was saying, that for 0.4 is 4 over 10, and we need the value to be over 100, and so you're just going to explain the steps in your line of reasoning. Okay. Example 8 is a fun example. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price? Yeah. If you talk about this one, this would actually mean that somebody's paying you to take the product. Now, occasionally that happens when I coupon shop, but not usually. All right, so yeah, no, we don't have decreases in price like that, because that would actually give you a negative value. So this would end up being a negative value. What would be helpful sometimes to think about in this is to actually do a numbered example. So let's give an example with some numbers so you can see what happens. Let's say the cost of a shirt, and we'll just use an easy value, is $10, okay? $10. And they want to have an increase of 150% in price. Well, if they increase the price by 100%, what would they give you? Yeah, it would be $20 if you increase it by 100%. So if you increase it by 150%, what's it going to end up being? 25, right? Yeah, so you increase it by 100, that's another, or 100%, that's another $10, so you get 20, and then increase it 50% more, it's another $5. What if we did a decrease? Let's do a decrease of 100%. If you did a decrease of 100%, that would be 0. So if you did a decrease of 150% on this particular set, you'd actually end up with negative $5. In other words, you get to the cash register and they let you take the shirt out and they give you $5 to leave the building. Yeah, that doesn't work. I mean, we don't do our prices that way. Okay. Last topic in this section is interest. I don't think we're going to finish this, but let's actually see how far we can get. All right, so interest is the amount of money you pay or earn to borrow or lend money. So when you put your money in the bank in a savings account, interest is the amount of money the bank gives you for leaving your money on deposit with them. If you borrow money for a car, your student loans, a house, those kinds of things, then interest is what you pay the bank in order to have the ability for them to be the one right now paying for your item, right? So that's what interest is. So interest is a good thing and a bad thing. I mean, and not just for the person collecting or receiving it, but also based on whether you're borrowing or lending it, right? Principal is the original amount that you've used to determine your interest. So if it's a savings account, you put money there, then the principal is the amount of money you put in the savings account. If it's a loan that you've taken money away from the bank or the lending institution, then the principal is the amount of money you borrowed from them. And then your interest rate is a percent used to determine your interest. And for the most part, we call this R, and we need to turn it into a decimal. Okay, so we put it into decimal form. All right. There are two ways to calculate interest. One is simple interest. Simple interest is usually calculated when somebody's doing a personal loan with someone else. So Like your parents give you a little bit of money so that you can go buy the whatever, and then you're going to pay them back a set amount of money. Okay, that's usually what we use as simple interest. It's the simplest to mess with. It's not what's typically used at a lending institution like a bank or a credit union or something like that, Sally Mae. They're not going to use simple interest. They're going to use something called compound interest. So what is compound interest? Well, actually, compound interest is both in your favor and not in your favor. What compound interest does is compound interest calculates your interest based on how much money you have right now. So if you owe a lot of money at the beginning of a loan, the interest you're paying is very high. But the benefit of that is that as you get towards the end of the loan, the amount of money that you owe on the interest for that loan is low because you don't owe them as much money still. Okay, so it's based on the current amount that you owe them on the product. Simple interest just finds out that it's sometimes also called add-on interest. Finds out how much the interest would be on the original price of the loan, and that's what you have to pay every month. So at the beginning, it sounds great because you're not paying as much on the interest, but at the end, it starts to sound like, oh my goodness, I don't even owe you that much, and I'm still paying that much in interest. So that's kind of the difference between the two. These letters, let me just identify for you what they are. So P is principal. So that's this one up here. So P is the principal. R is the interest rate. That's the R right here that we have to turn it into a decimal amount. And then T, what do you think that one is? Time. And it is very important for you to realize that the time in these formulas is always calculated in years. So if they talk about a loan that's an 18-month loan, you've got to turn that into years, 1.5. Don't put 18 in for T. Okay, so T is always measured in years. Whatever you have to do to change it, turn it into years. Now you see all those same letters listed in the second formula for compound interest, but what also do you see? N. N is the number of compoundings per year. So this is what the bank does. It's how often does the bank look at this amount and calculate your interest? Either for you to give it to you or for you to charge it to you. How often do they do that? So there's lots of different answers to that. It depends on the arrangement that you have with the bank. They might do it monthly. So if they did it monthly, what would N be? 12, because it'd be 12 times a year. What if they did it weekly? It'd be 52. What if they did it annually? 1. What would they do if they did it quarterly? That's a good one. You hear that one done a lot. Quarterly. 4 quarters in a dollar. Yeah, you do 4. So it depends on what you're actually have in the problem and how it's set up. Here's the last thing I'll say today. Notice this statement right here. You see this? The formula that I'm giving you is not the formula they're using in your book. And I don't usually do that. So that's why I want to make perfectly clear to you that I am doing that. The reason I'm doing it is because the formula that I'm giving you is the one that is in most books that you see. If you've worked with interest before, and I'm sure you have at some point, this is probably the one that you worked with. The one in the book is an equivalent form, but it does not look the same, and it is not the most common one used. So I want us to use the one that we see more often, okay? We will pick back up next time and finish section 7.4, and we will move on into 9.1, okay?